Hello, Dr. Knight and classmates. My name is Susie Towsey. This is my final research project for this course. The purpose of my study is to identify if there's a higher probability that a police officer would get assaulted with a firearm, knife, or other cutting instrument at a specific time, day of the week, or season of the year. Researchers analyze statistical data to help individuals gain a better understanding of the world around them and initiate positive social change. The data for this study is derived from the 2017 Uniform Crime Report regarding police officers assaulted or injured with a firearm, knife, or other cutting instrument while on duty. As you can see by the data on the screen, in the ID section, this is the number of participants. There is 102 participants in this study. These are all law enforcement officers that reported being assaulted under these circumstances in the year 2017. I also entered the officer's age, gender, race, time of the day of the week the assault occurred, the season the assault occurred. I also added years of service, as you can see in these different sections. However, the Uniform Crime Report, the way that they gathered the data or published the data, did not tell you exactly what officer's age and race and gender, so I had to use a random counter on the internet to put some of this data in there, so that was one of the limitations of the study. And obviously, if you did this study, you would get results from a survey and you'd be able to enter this data correctly. I also want to note that I did I manipulated a little bit of the data in the seasons. It's supposed to be for each month of the year, and instead I've put those into 4 different groups as spring, summer, fall, and winter, so the data was easier to read. Otherwise, it just had a lot of data to go through. I developed 3 research questions for my analysis. The first one is, do differences exist in a specified time a police officer gets assaulted in the season of the year the assault occurred? The null hypothesis for that would be there is a difference in the specified time a police officer gets assaulted in the season of the year the assault occurred. And the alternative hypothesis is there is no difference in the specified time a police officer gets assaulted in the season of the year the assault occurred. The second research question is, do differences exist in a specified time an officer gets assaulted in the day of the week? And the null hypothesis would be there is a difference in the specified time an officer gets assaulted in the day of the week. And then the alternative is there is no difference in the specified time an officer gets assaulted in the day of the week. The third research question is, does an interaction exist between the seasons of the year, day of the week, and the assault that occurred on the police officer? The null hypothesis is there is an interaction between the season of year and the day of the week an assault occurred on the police officer, and then the alternative is there is no interaction between the season of the year and the day of the week an assault occurred on a police officer. For this data set, I'm using a quantitative process encompassing a non-experimental design utilizing a two-way ANOVA and SPSS, which also allows the researcher to determine if an interaction exists between the independent variables, which is days of the week, and the season of the year on the dependent variable time of assault. And I'll change that data view so you can see how the variables are measured. For a two-way ANOVA, there are 6 assumptions for the results to be valid that must be met by the researcher. The first assumption is in a two-way ANOVA is the dependent variable must be measured on a continuous scale, and that is time. And you can see that this is a continuous scale. And then the second assumption is that the independent variables should each consist of 2 or more categorical independent groups, such as the day of the week, which is Monday, Tuesday, and we'll look at that here. And if you look at the variables, that's how they're entered. And then the other independent variable is seasons, and that also has 4 different categories. So it meets that second assumption. To start this analysis, what I'm going to go to is Analyze, and then General Linear Model, then Univariate, and select that. Then I'm going to put my dependent variable in there, which you can only put 1, which is the time of assault. And then I'm going to do my fixed factors, which are my nominal variables or my independent variables. So I'm sorry if I said that wrong. The dependent variable is time of assault, and the day of the week is my independent variable, along with season, which is my other independent variable. I'm going to go to the options section. I'm going to pick my descriptive statistics, the estimate of effect size, and the homogeneity test, and then just click continue. I'm also going to go to the estimated marginal means and select all these variables and put them over here, and select the Bonferroni. So the marginal means is going to be different than my descriptive statistical means because my sample size is unequal across levels. I'm also going to click on plots because a plot is a good way to see if there's an actual interaction, and I would want to put in the separate line section the one that has the least number of options, which is seasons, and then I'll put my days of the week up here since it has 7 and add those down there and continue. I do want to address the model, which is this full factorial, which is the sums of squares type 3. This happens to be, it is an unweighted mean approach, so it pretends that the sample sizes are not unequal. So it's probably one of the best ones to select for this data since I do have unequal sample sizes. Now that we have the data all situated, I'm going to go ahead and analyze it. And take a look at it and just move this over. So if we look at it between subject factors to see there is some unequal variances here. Some of the sample sizes aren't. They're very similar here, but then you've got a 10 and an 8, which are drastically different than a 28. So that just kind of adjusts for that using that sums of type 3 squares. So in the descriptive statistics, we have the means across all levels. So we have the time of assault, the days of the week here, and then the fall, spring, summer, the seasons of the year. And then you can look at these numbers over here. We've got, you know, these are the totals, but you have like 4, 3, 2, 1. So, and then down here we have quite a big difference. So there is unequal levels there. When you look at the standard deviation, and these numbers may be larger with the smaller sample size. So down here, I think there was one that was pretty high. It was like here. That usually indicates that there is probably a violation of the homogeneity of variance, and which is bad. But when we go down to the Levene's test, it kind of gives you an idea of what you're looking for. And in the Levene's, you're actually looking for a value over the p-value, which is the 0.05, to address this. And the lower numbers like this indicate that you violated this third assumption for this two-way ANOVA, which is the independence of observation or the homogeneity of variance. So to clarify this, the Levene's test measures the robustness of how well false reporting of unequal variances occurs in fact, if they are equal. So also Levene's measures the power in which the test reports the correct unequal variances. So the Levene's test is testing the hypothesis and indicates if group variances are equal. If they are Cauchy distribution, which is like unequal, then for the best to determine the best outcome, they suggest that you use the trim mean, which is that 0.014, which is still less than the p-value, the 0.05. So this indicates that we would have to the null hypothesis gets rejected, indicating that the variances are not equal. One way to look to see if there's a statistically significant difference is looking at the plot plan. And typically if the lines are, this looks like, you know, a maze, a string mess. But typically if they are parallel to one another, there is typically not a statistically significant interaction. And if they're like, so I'm trying to find one that would maybe like this one, there might be an interaction between summer, this red line, and some of the other ones, but it's really difficult to read this plot plan because the lines are so over one another. The other way to look at is to look at the pairwise comparison to see if there's a significant difference there. And if we look here, there isn't. Like this is the closest one, like fall and spring is the closest. It's just a little bit over the 0.05. And then if we look up at the test between subject effects, the significant difference here is it does show that there's a significant difference because it is under the 0.5, which is this 0.33 seasons, but it doesn't exactly tell you in a two-way ANOVA which season it is that is causing the interaction. And the other pairwise comparison, which is the days of the week, and then each day is comparing it to the other days. the significant level is way over the 0.5, so there is not a statistically significant difference in the day of the week. So the ultimate conclusion of this sample. So for the null hypothesis, or the first research question, we would accept the null hypothesis, which is there is a significant difference in the specific time a police officer gets assaulted in the time of year, which would be the season. And then the other one, we would reject the null. So research question number 2, that there is no difference in the specific time an officer gets assaulted in the day of the week. So we'd accept the alternative hypothesis there, which that was it. And then we would also accept the alternative hypothesis for the interaction, which there's no interaction between the time of year and day of the week that the assault occurred on a police officer. So that concludes my research project. I hope you enjoyed it.